So here you can see the management console, and these are all the different vendor switches which are working with our controller. So it shows like the Arista, Intel, Dell, Extreme, and many of them. And this topology which you see here is a class topology. So it's a great thing. You're able to create a class topology with multiple different vendors and able to create a high bandwidth network fabric, for your data center. And this shows you a virtual tenant network, which I was saying. So it models, for example, the virtual router, the bridges. So it provides you with the entire topology specification. And you can go and add policies into this whole virtual network. You can visualize this whole network. Now you can also see two things here. You can track flows. So you can see here that there is a two virtual switches, and you can see the whole blue lines, which is basically showing tracking the flow in the virtual network. And this is your physical network. And this whole physical network has been automatically discovered and created. And you can also track in this whole complex diagram how the flows are moving from one place to another. So it gives you more troubleshooting, gives you a more visibility of the network, and it is using all the different switch vendors in there. So here you'll see the different switch vendors are essentially connecting to the network. So we have all the vendors which you see here, and all of them are essentially supporting OpenFlow 1.0. And with that 1.0, you're able to support a multipath network fabric connecting them. So that's the basic part of the interoperability we're showing here. So let's move on to the other side of it. So here is basically showing what we were talking about there, that how the different appliances and the application can come and make a use of the whole SDN. And I think here, let me show you just for a good expression of what you can do with the APIs. We are showing here is a application company called Real Status, a visualization of the whole network here in a 3-dimension. And it's all done using just the REST APIs. Now, one of them is that the other cases which we have here is Silver Peak. It is a WAN optimization company, and it shows that how you can scale or insert WAN optimizer between the data center using the SDN. We are also showing here the vArmor, which is a security thing. So what they're doing is, they are using their DPI engines to track an application and then automatically, let's say, throttle that particular application or create rules to drop the applications. So these are all the cases of essentially appliances using our programmable flow. This is NEC's first virtual switch product for the Microsoft Hyper-V. Okay. And it is total created, and it supports the OpenFlow, and it also supports all the vendor extensions which we have. So now any of the Hyper-V environments can use our PF1000 product to have a virtual switch and be a part of the entire OpenFlow ecosystem, apart from OVS for the KVM. So now you have two virtual switches, OpenFlow capable, the Hyper-V based and the KVM based OVS in this thing. So let's come to the next. Yeah.
Can you deploy the PF1000 without a controller?
No, it is essentially working with the controller because it's a purely an OpenFlow switch. So this is the RedWhere demo, and it's a very interesting security demo which we were discussing there, that you are able to use the APIs to find out if there is a DOS attack going on, using the API to go and shift the traffic to the RedWhere device, where the RedWhere device has a DPI engine that will go into deep packet inspection, see there is a real DOS attack, scrub the traffic before it even enters the whole thing. So in this case, maybe what we can do is show a little bit of a demo of how this works. So what we are going to do is, we are running a normal network, and then we will emulate a DDoS type of a traffic. And we'll see how the controller automatically switches.
Is the controller pulling statistics from OpenFlow 1.0?
Exactly.
Seeing that as an escalation and matches some sort of heuristic, and then just doing setting a punt path up so it scrubs it in the controller?
Yes, so it will inject a new path automatically so that all those DOS traffic, just those DOS traffic gets redirected into the... Yes, exactly. So this is the case of a directly going from one server to another server, just a normal path, normal behavior. Now, this is what is creating the DOS traffic, just a simple emulation of the scenario. Okay, now we go back to the console there. Go to the console there. Some time? Yeah. Yeah, it takes some time to.
So he's doing a DDoS attack, and so traffic is coming across a normal path on a network. Controller's inspecting the traffic, so 410 spec gives information about flows that come out. Controller says, hey, this is bad traffic. This matches a DDoS profile. They'll give you the switching, setting that specific traffic on a punt path.
So now you can see this traffic which was directly going is now moving into the RedWhere device and then going into there. And the RedWhere device using the DPI is essentially scrubbing the traffic. What will happen is, and you can see also in the virtual network that this is going into the RedWhere. We show both the physical and the virtual. Now if you stop that it will find out the DOS attack is gone, he will revert back. So that's how you're able to scale. Essentially all these appliances which are both costly and becomes a choke point, right? Yeah. You're doing it only when it is reactively demanded. So this is the OpenStack meets OpenFlow. So in a high level, what we have is the Quantum plugin, NEC plugin, and the NEC plugin is talking to the controller, the program flow controller, and the program flow controller is now managing both the virtual switches as well as the physical switches, and then providing you with all the network fabric level functionalities that you want. So this is the same panel you have seen, right? So let's go to the horizon, which is the OpenStack console. You are trying to create a particular instance, an image, firing it using the OpenStack. You are now connecting to assigning it to a layer 2 network. It's showing that it is getting fired here, the booting up. Everything is automated from there on. It will automatically connect to your OpenFlow network, and it will be part of that same layer 2 network which you wanted, and you will have the connection between the VMs. So that's what we are going to show here. So we are creating like 2 VMs, and they will be connected using this whole OpenFlow network, and you will see that that you're able to ping them. So these are the 2 VMs we have just created. We are going to that plot, we are refreshing it, and you can see that those VMs are actually now showing up here into the actual network visualization. And then we are going into one of the VM and just showing like you are able to ping between the VMs, which shows like the connectivity on the whole layer 2 network. So that shows like how you're basically able to automate the whole VM creation to the L2 creation to their connectivity, and everything totally you're able to manage from the Horizon console for the OpenStack. So that's a big driver case for now, that how simplifies it does with the OpenStack orchestration part.